Why is water's molecular structure so unique? Imagine a tiny molecule that holds the power to shape life, influence weather, and carve out the landscapes around us. That molecule is water, and its structure is what makes it so extraordinary. At its core, a water molecule is made of two hydrogen atoms bonded to one oxygen atom. These bonds form a bent shape with an angle of about 104.5 degrees between the hydrogen atoms. This shape happens because the oxygen atom has two pairs of electrons that are not involved in bonding, called lone pairs. These lone pairs push the hydrogen atoms apart, giving the molecule its distinctive bend. Because of this shape, water becomes a polar molecule. That means one side of the molecule has a slight negative charge near the oxygen, and the other side has a slight positive charge near the hydrogen atoms. This separation of charges creates a dipole, which makes water molecules attract each other and other polar substances. The most important result of this polarity is water's ability to form hydrogen bonds. A hydrogen bond is a weak attraction between the positive hydrogen of one water molecule and the negative oxygen of another. Even though these bonds are individually weak, they form a large network that influences many of water's properties. For example, water has high cohesion, which means its molecules stick tightly together. This causes water droplets to form and allows water to move up tiny tubes in plants through capillary action. Water also has a density anomaly. When water freezes into ice, the hydrogen bonds arrange the molecules into an open, cage-like structure. This makes ice less dense than liquid water, so it floats. This is why lakes freeze from the top down, insulating the water below. Water's hydrogen bonds also requiring more energy to break. That is why water has high melting and boiling points compared to similar molecules. It takes a lot of heat to change water from one state to another. Water's high heat capacity means it can absorb or releases large amounts of heat with only a small change in temperature. This helps regulate climates and keeps biological systems stable. Its polarity makes water an excellent solvent, able to dissolve many ionic and polar substances. This is why water is called the universal solvent and why it is essential for transporting nutrients in living organisms. Water also has more solid phases than most substances because of the flexible ways hydrogen bonds can arrange themselves. All these features come from water's molecular structure, which is a perfect example of how tiny details can have a huge impact on the world around us.